Hello everyone. So let's work on another problem. So this is a problem where an element has following current and voltage determine the element. So there is some kind of a unknown element. It is exhibiting the following characteristics for current and voltage. Okay. So let's see what is that element. So let's understand the diagram. So the above figure current is there. So 0 to 4, this is time in seconds. So the plot is given from 0 to 8 seconds and the current is gradually increasing from 0 to 2 seconds reaching 10 amperes at 2 seconds. Then it maintained at 10 amperes. Then again at 4 seconds the current starts reducing and reaches minus 10 amperes by 6 seconds and then again maintains at minus 10 amperes. So this is the about the current. Now on the other hand, it is found that the voltage was 15 volts plus between 0 to 2 and then the voltage is 0 between 2 to 4 and then again voltage is minus 30 between 4 to 6 and so on. Now if you notice, you see that whenever the current is constant, the voltage is not there. Whenever the current is changing, there is some voltage. So this looks like a inductance. Okay, so if I just look at this, EMF induced is nothing but L di by dt. So for the time being, I'm not considering a minus sign, assuming the direction. So I'm just worried about the magnetic magnitude only. So di by dt from this plot I can find out, and the EMF induced also I can find out. Based on that, I can determine the L. So that is what is the objective. So let's see what is di by dt between 0 to 2 seconds. Okay. So di by dt here is the slope of the current. So di is 10 amperes and time is 2 amperes. So this is nothing. So this is 0 to 2 seconds. Okay. So I'm only worried about this part. So di by dt is nothing but the current is increasing to 10 amperes and the change in time is 2, so this is nothing but 5, and whereas the voltage is 15 volts, as we can see from here, constant. So therefore what is the L? So 15 equal to L into 5, that is amperes. So therefore L is 3 henries, okay, according to this. Now, what happens between 2 to 4 seconds? Okay. So, during the time between 2 to 4 seconds, di by dt is 0. There is no change in the current. So, therefore, voltage is also not there. Okay. So, that is again we understood. What happens between 4 to 6 seconds? So, between 4 to 6 seconds, di by dt is nothing but, so the current, the final value of current is minus 10, initial value of current is 10. So minus 10 minus 10. So this is like minus 20 is the change in the current. And the time, final time is 6 seconds, initial time is 4 seconds. So this is 6 minus 4 is 2 seconds. So this is minus 10. So di by dt is minus 10. So therefore again I can once again read from the plot, between 4 to 6 the voltage is minus 30. Okay, so therefore minus 30 is equal to L di by dt, that is minus 10. So again from this also, so L will be minus 30 by minus 10, so it will be 3 henries. So this confirms that the inductance is 3 henries. Okay. So and the remaining time the current is maintained constant, and therefore the uh, the voltage is also 0. Okay. So I think this, with this short question, we are able to determine that the element is an inductor of 3 henries. Okay. So the element is an inductor of 3 henries. Okay.